Alright, thank you very much for having me. I'm Shunsuke at Brown University. I also defended very recently. Okay, so let me, so this paper, Economies of Density and Conservation in the Rainforest. Joined with Yoshito to the University of Tokyo and Mari at the Tsuda University. So I study tropical forests, especially populated by, especially tropical forests populated by indigenous populations. And we have rising concerns about the role of small-scale farmers in conservation. In this kind of environment, policymakers face the inherent trade-off between improving the local population welfare and improving the population welfare and conserving the rainforest. For example, if we restrict forest clearing, then deforestation may be reduced, but also agricultural income will be reduced, and then human welfare will be undermined. In addition, human adaptation through sectoral reallocation or spatial reallocation of economic activity may also undermine conservation policy goals. For example, if we increase the cost of forest clearing, then local population may just shift from agriculture to other kinds of natural resource extractions, such as fishing and hunting, which could lead to more biodiversity loss. So, which means that reducing one environmental cost may increase another environmental cost. Or if we set protected areas that restrict human settlement in a particular location, then population may just move from that area to other areas, and then its impact on total resource depletion is not clear. So, to think about these problems, we need a general equilibrium framework. And then the research question is that are there policies that improve both local population welfare and ecological conservation? In order to answer this question, we take the following steps. First, we build a spatial general equilibrium model that formalizes such human nature interactions, focusing on multiple rural sectors. And then we estimate the model using data from river basins in the Peruvian Amazon. The model's key parameters are density externalities that explain how population density affects productivity in the rural sectors. Just to make the definition clear, if higher population density increases productivity, it's called agglomeration. In contrast, if higher population density decreases productivity, it's congestion. And you see different colors and throughout the presentation. If you see blue, I'm talking about the agglomeration. And if you see red, I'm talking about the opposite force, congestion. Okay. Then, to answer the question, we evaluate counterfactual policies, focusing on protection areas, protected areas, protection policies, and river transport infrastructure. Let me preview the findings. First, by exploiting the plausibly exogenous variation in the structure of river networks, we find that the agglomeration externality in agricultural production outweighs dispersion forces in access to land for agriculture, which implies that at a particular location, higher population concentration leads to higher agricultural productivity as well as less deforestation per farmer. Okay? And second, we also find a strong congestion externality with spatial spillovers from surrounding populations in natural resource extraction. And we find that these density externalities are quantitatively important. For example, by shutting down the agglomeration externality in agricultural production, local population welfare decreases by more than 10%, and total deforestation as an aggregate outcome in general equilibrium increases by more than 30%. The mechanism behind the congestion is very straightforward, which is competition over finite resources. On the other hand, the mechanism behind the agglomeration externality in the rural sector is not immediately obvious, in part because agglomeration has typically been discussed in urban settings. So, and we find that economies of scale in transport technology and agricultural intensification are playing important roles behind the agglomeration. Finally, counterfactuals demonstrate that combining well-targeted place-based protection policies and transport infrastructure can simultaneously achieve higher welfare of local populations, less deforestation, and less natural resource depletion. Importantly, well-targeting means that spatial targeting matters for both types of policies. For example, the direction of deforestation impacts, so the location of transport infrastructure improvement within the transport network determines whether total deforestation increases or decreases. So we often ask if improving infrastructure can increase or decrease deforestation.